saddle up my horse and I'm riding to the city. I make a lot of noise, 'cause the girls they are so.
All right, we'll settle up. We've got derivative of the inverse tonight. So a lot of us have just straight up memorized this formula, and I just want to talk about where it comes from for a minute that I think will make this more beneficial in understanding what we're actually doing. So one thing to recall, if two functions are actually inverses, okay, then when you compose f and f inverse of x, you will always get x. So that's how you test if a function and another function are inverses of each other. For example, if I said f of x equals x squared and g of x equals the square root of x, and I compose those two, so if I did square root of x squared, I should get just x. Or if you compose it the other way, if I said the square root of x squared, I should just get x. Okay, so again, I evaluated f of g of x and g of f of x, and both turned out to equal x. Therefore, they are truly inverses of each other. So keeping that in mind, if I have f of f inverse of x, and I derive it, I should come up with a formula that hopefully you've memorized by now. So let's take the derivative of this function. Derivative of the outside is f prime. Keep the inside. Now I need to derive the inside, so I'm going to use d dx to represent the derivative of the inside equals 1. And my goal is to solve for the derivative of the inverse. So basically I would just say divide this junk to the other side. So I'm dividing both sides by f prime of f inverse of x. So here's your rule. The derivative of f inverse of x, okay, the derivative of the inverse, is 1 over f prime of f inverse of x. Okay, so that's the one that it's probably a million times easier to memorize. Otherwise, you're going to have to start with this every time and derive it. So like we said, just memorize this. Before we dive right in, one other helpful hint. If I said g of x equals 3x plus 8, and I want to find g of 2. Okay, by now you should know basically you're replacing all the x's with 2. So I would get 3 times 2 plus 8, and I've got 14. However, if I said find g inverse of 2, I'm no longer plugging 2 into x. The whole key is that you're plugging 2 into y. So I would say this time 2 equals 3x plus 8. Subtract my 8, negative 6 equals 3x, and x equals negative 2. Okay, so be real careful. When you're finding the inverse, you should be plugging this into y. Alright, let's attack some problems here. Alright, so I think the easiest way to attack these is just to first start memorizing the formula. So question 1, let f be a differentiable function such that they give you f of 2, f of 5, f prime of 2, f prime of 5. The function g is differentiable, and g of x equals f prime of x. That's huge. What is the value of g prime of 5? So you'll notice nowhere did they come out and literally in English words say, find the derivative of the inverse. They're using symbol notation here. So I say, okay, I clearly want a derivative. It says g prime, and well, what is g? G is the inverse of f. So that's what's hinting to you, derivative of the inverse. So I think the slower you approach this, the easier it's going to be. I'm going to start by saying the derivative of the inverse formula. So the derivative, and I don't think you should take any shortcuts here, of the inverse of f of x is 1 over f prime of f inverse of x. Now I'm going to replace some information. I really know that the inverse of f is equivalent to g. So I'm really saying that the derivative of, I'm going to replace the inverse of f with g of x, equals 1 over f prime of g of x. Okay, so again, I'm just taking nice small steps here, and the slower you write this, the easier it will be. Now, I want to say I want to take the derivative of g of 5 which is going to be 1 over f prime of g of 5. Alright, so I'm first going to evaluate g of 5. So you'll notice if I go look up here, none of them say g. Okay, and they're not going to, because remember, g is the inverse of f. So if you have 5 and you want to plug it into f's inverse, you're not plugging it into x, you're plugging it into y. So I am looking for a 5 to be in the y value. So if I look at these two functions, hopefully it's clear that this is the one we want. So I can say that this is 1 over f prime of 2. So let me say that one more time. I'm plugging 5 into g, okay, but there's no g function. G is the inverse of f. So I'm really plugging 5 into the y value when it says inverse. So that's why I'm using this one. Now I get 1 over f prime of 2, and you'll notice they gave me f prime of 2 as -7. So my final answer is just -1/7. You'll notice that they gave me some extra information that I didn't even need. Okay, so make sure again, the slower you write this and the cleaner you keep it, the easier it will be. Let's try another. 2. Let f be the function defined by, there it is, g of x equals f inverse. There's my key to the whole problem. What is the value of g prime of x? So again, I'm going to start with my definition. The derivative of the inverse of f is equal to 1 over f prime of f inverse of x. Okay, so now I'm going to replace some information. I really want the derivative of g, and g is the inverse. Okay, so I can replace every place I put f inverse, I'm going to replace it with g. So the derivative of g of x is actually 1 over f prime of g of x. So one more time, every place I saw f inverse, I put g of x. And now I'm saying the derivative of g of 6 is equal to 1 over f prime of g of 6. And look how handy that is. They gave me g of 6. So this is really 1 over f prime of 0. And now you'll notice they didn't give me f prime, so I do have to do a little work on my own. They gave me f here, so I'm going to quickly go ahead and find f prime. So f prime of x is equal to e to the 3x times 3 minus 2x. And if I substitute in my 0, f prime of 0 equals 3 times e to the 0 is 1 minus 0. So I've got 1 over 3. Okay, so each problem's a tad bit different, but just take your time, and the more steps you write, like I said, the easier it will be. Alright, so let f be the function defined by this. Here's my key. G of x is the same thing as f inverse. I want g prime of 8. So again, the derivative of f inverse of x is equal to 1 over f prime of f inverse of x. Maybe you've got the hang of it and you can pause it and try it on your own. That would be awesome. I'll walk through it again, but like I said, pause it, see if you get the same answer. So again, I'm going to replace every f inverse with g of x. Okay, I'm evaluating g prime of 8, so I've got the derivative of g of 8. It's 1 over f prime of g of 8. Okay, now at this point, I don't have g of 8. I don't even have f of 8, or f of something equals 8. So again, I'm going to take 8, and I'm plugging it into g, which is the inverse. And I just want to be clear, when you plug into the inverse, you are plugging into y. So I am setting 8 equal to the ln of x plus 5. I'm going to subtract my 5. 3 equals the ln of x. I'm going to use a nice zap rule, raise e to the both sides here. And I get x equals e cubed. So if I continue, I've got 1 over f prime of e cubed. Now again, I got to do a little work on my own. They don't tell me what f prime is. I just know f of x. So I'm going to have to find f prime off to the side. Derivative of the ln of x is 1 over x. And if I want f prime of e cubed, I've got 1 over e cubed. Now that's not my final answer, that's just my denominator. So I should now get 1 over 1 over e cubed, which of course is just e cubed. So again, if at any point something went too fast for you, this should be a review, but pause it, rewind it, try it on your own again. Alright, well we've made it to the last question for the night. So, if f inverse is the inverse of f, write the equation for a tangent line to the graph of y equals f inverse at x equals 1. So let's just break it down. I mean, the first thing I see is write the equation of a tangent line. So I'm starting off by y minus y1 equals m times x minus x1. And the one value that they do tell me right off the bat is that x equals 1. So y minus y1 equals m times x minus 1. So hopefully you're thinking, okay, the only two things I need are a y value and a slope. So typically getting the y value is usually easiest, so let's start with that. If x is 1, I would normally plug 1 into x and solve for y. But I'm talking about the inverse. Okay, so we've got to go backwards. We actually have to plug 1 into y. Okay, and hopefully you figured that out by now. We've said that in almost every slide. When we plug into the inverse, we're plugging into y, not into x. So here's how I attack this. I'm going to use function f, okay, because I'm finding f inverse, so I'm looking at function f here, and I'm plugging 1 into the y variable. So here's 1 into the y. And you'll notice that corresponds to an x value of 3. So that happens to be my new y value. So let me say that again if I went too fast for you. I'm taking my x value, plugging it into the inverse, which means plug it into the y value. And it corresponds to a value of 3. So my new equation so far looks like y minus 3 equals the slope times x minus 1. Alright, I've got one more piece. I need to get the slope. So you'll notice that means take the derivative, and I'm doing it of the inverse. So I'm going to show some work off to the side and say the derivative of f inverse of x equals 1 over f prime of f inverse of x. Okay, so I've got 1 over f prime of f inverse of 1. And I know f inverse of 1, I just found. Oops. So again, f inverse of 1 means plug 1 into y. That corresponds to that 3. So I have 1 over f prime of 3. Now I need f prime. And I don't have a function to take the derivative of. They give me f prime. So I go to f prime row here. I find my 3. And that corresponds to a value of negative 2. So I get 1 over negative 2 for my slope. Substitute that in, and you've got the equation of your line. So this last one's a very important piece. If you think you missed any of it, go back and replay it. And we look forward to seeing you in class tomorrow. Have a great night.